More problem. So vertical motion, if you guys, if any of you guys are in physics, you've seen some stuff like this before, right? So if you throw an object upwards, it follows a path described by this formula shown below. We know, because we live here on planet Earth, if you throw something, it's going to eventually come down. And this formula is going to get us what we need. So we have -1/2, and this is times g. This g is gravity, and here on Earth that's 32. If you're in imperial units, usually you're in metric system, so it's like 9.8 meters per second squared. And then our velocity, this v naught, this v with this subscript of 0, we call that v naught. And so that is our initial velocity, and h naught, that is our initial height. And so we've got all of what everything means over here. If we plug everything in, we know what g is, we know what t is, we know what v naught, t, and h is. Our output is the height of this object at some time. So let's take a look at our first problem that we're going to do, and then you guys will do a problem. So a diver springs from the edge of a cliff that is 80 feet above the ocean floor. So that 80 feet above the ocean floor, that is h naught. So h naught is 80 feet. And with an initial upward velocity, so that initial velocity, that's v naught, and that's 8 feet per second. And it says, how long will it take the diver to reach the water? So we figured out what h naught and v naught are. We're going to substitute those values into my equation, and we're going to simplify. And we're trying to figure out what this h of t is, right? We're trying to figure out, we need to think about this for a second too, right? So our v naught is 8 feet per second. We're not going to put feet, we're not going to put units in there, no feet per second. And our h naught that we're adding, that's 80. Now, we're missing something right here, and we need to think about what that is. This is a diver. He springs from the edge of a cliff 80 feet up in the air, and so it looks something like this, right? He's up on this cliff, and here's our diver. He's going to jump in the water. Down here, I probably shouldn't have drawn it like that. I should have drawn, right, waves, or those are terrible waves. They look more like a table saw blade or something. Anyway, the diver jumps in. He's going to jump up a little bit. He's going to come back down. This h of t, this gives us our height at some time, right, at any time. And so this h of t, this is the height for a certain time. Well, we're saying that this distance from here to here is 80 feet. So his initial starting height is 80 feet. He's 80 feet above the water. When he hits the water, his final height is going to be 0. We're going to plug that in. And so we've got our 8 and our 80, and now we're just going to figure out how long it takes him to splash down in our water over here. So it's our formula. I'll write it over here just to make sure you have it. And every time you use this formula, you should write it out. X equals -b plus or minus the square root of b squared minus 4 times a times c. And the whole thing is over 2 times a. So let's get some stuff going on over here. We have x is equal to -b, which is -8, plus or minus the square root of b squared, so 8 squared. I didn't put this in parentheses when I wrote this out. This is not a negative number, so I don't have to worry about that. We can just put it in as 8 squared. So b squared minus 4 times a, which is -16, times c, which is 80. And that's all over 2 times a, so 2 times -16. Before we put this big giant mess in the calculator, I want to clean it up just a little bit. And so we know we've got our -8's not going to change. This is going to be plus or minus. Let's write that out a little bit better. Plus or minus the square root. I calculated the discriminant, the value of the discriminant earlier, and so the discriminant is 5,184. And this is all over 2 times -16, so that's -32. And now I'm going to show you guys how to put this whole thing in your calculator, and we should get 2 different solutions because we have our plus and our minus, right? I'm not going to write them as two separate equations. So grab your calculator, let's get this guy turned on, and let's plug some stuff in. So step by step, we don't want to use like parentheses and a bunch of stuff like that. Our calculators have the nice fraction feature, and so we want to put this in as a fraction. So we're going to go alpha y equals, and we want to just hit enter to get that to pop up, and there's our fraction. So we're going to do -8. We can't do plus or minus. We're going to have to do it two separate times. I do plus only because it's the number on the symbol on top. So -8 plus the square root of 5184. We're going to arrow key down, and we're dividing by -32. So my first time interval is -2. So over here, and remember this, I know I wrote this as x's because we can't really plug t's into our calculator and have it solve it. We have to plug in x's, but this is t, this is time. So t is equal to, just to like keep on track, so t is -2, and that would be seconds, right? Let's check our units. So feet per second, right? So it took him 2 seconds to splash down, or -2 seconds to splash down. And we're going to come back and talk about that. Let's pull up my calculator. The nice thing about these calculators is we can do some kind of fun editing. So I move up, I'm going to copy this, and I'm just going to scroll over, and I'm going to change this to subtraction. So now it's -8 minus, that's going to give me my other solution. And this is 5/2, so that's 2.5, right? We get t is equal to 5/2, or 2.5 seconds. And it says, so how long will it take the diver to reach the water? One of these is extraneous. He can't go back in time and hit the water before he jumped in. So this is our solution. It took him 2.5 seconds, which seems kind of, it's like a long time to fall. No thanks. Let's talk about the negative solution for a minute. What this negative solution gives us, because remember this is a quadratic, it's an x squared, it's that parabolic shape. So this, if we were to extend this line and extend my water over here, if he were to start in the water and like magically spring up to 80 feet and then fall back down, this would be a starting position. But he can't, like I said, he cannot go back in time, so this answer is extraneous. And that's what we've got. I hope you guys like this, and I will talk to you later.